This video will discuss the average rate of change. And you may know the average rate of change is the slope. And all the average rate of change is the slope between 2 points on a curve. Those 2 points form a line, and that line that we're going to look at is called the secant line. So we're finding the slope of the secant line here. And we know that the slope is generally equal to the change in the y's, or delta y, over the change in the x, which is delta x. Also, a number of ways we can write this. We can write this as the change in the output, which stands for y, over the change in the input, which stands for x. Or you may see it as y2 minus y1 over x2 minus x1. These are the ways you know slope. And we're going to reconvert y2 and y1 to their new function notations, which is going to be the general way we're going to find this. So we're going to call y2 f of b, which is the second point on the graph. So here is f of b up here, minus the change in your other f, your other y, which is f of a. So here is f of a down here. And then we want to find the change in their horizontal distance. So that would just be b minus a. When we find the slope of this secant line, then here's how we're going to do it. We're going to find the slope of this line is called the average rate of change. We'll calculate the outputs using the given inputs. This is the top of the fraction, or this part up here. And then we'll find the difference between the given inputs, which is the bottom of the fraction. So it's very simple. So it says, find the average rate of change for the function f of x equals 2x squared plus 1, where x1 is negative 2 and x2 is equal to 5. So the endpoints are negative 2 to 5. So we'll first calculate, here is the f of b. Here's the second point. That's where it's stopping at. Here's where it's starting at. So we'll calculate the second point first, f of 5. So f of 5 is equal to 2 times 5 squared plus 1. And all I've done is I've plugged in 5 for the x. So we'll calculate this with our order of operations, which says 5 squared, 25, times 2 is 50, plus 1 equals 51. F of a, or in this case, f of negative 2, equals 2 times negative 2 squared plus 1. So again, all I've done is I've plugged in negative 2 into that x. Order of operations says do the exponents first. Negative 2 squared is a positive 4, times 2 is 8, plus 1 equals 9. So now that I have the outputs for both these, I'm going to do the slope. We call slope m. So m is equal to the first one I calculated, which was 51, minus the second one, which is 9, divided by the difference in the inputs. And the inputs are 5 minus 2. 51 minus 9 is going to be 42, over 5 minus 2 is 3. And so 42 divided by 3, we'll simplify that. That gives us a slope of 14. So all this is just finding slope. So let's do one more. And this one says x cubed, that should just be a plus, not a plus or minus. Plus 2x plus 8 from x1 equals negative 2 to x2 equals 2. So again, we'll go from second point first, which is ending at 2, starting at negative 2. So we evaluate f of 2 for this function. That's 2 cubed plus 2 times 2 plus 8. 2 cubed is 8, plus 2 times 2 is 4, plus another 8. So this will be equal to 20. And then f of negative 2 is negative 2 cubed plus 2 times negative 2 plus 8. Negative 2 cubed is a negative 8. 2 times negative 2 is a negative 4 plus 8. So the negative and positives cancel, so this will just be negative 4. So to find this slope now, m is equal to your 20 minus 4 minus a negative 4 divided by the difference in the inputs. So that'll be 2 minus negative 2. When you have negatives pushed together, they become positives. So when I calculate this, I get 20 minus a minus 4 becomes 20 plus 4, which is 24, over 2 minus a negative 2 becomes 2 plus 2. And I get 24 divided by 6, 24 divided by 4, which is equal to 6. So the slope there for that one is 6.